friction. That's what's happening, right? No, it's not friction. I'll show you a better example here. This one is very clear that there's no friction out there. See what happens. It like levitates through the inside, right? Because on contact but it floats to the inside. So the question is, why is this happening? And this has appeared multiple times in your exam in many different ways. আমরা সবগুলো ডিসকাস করব, বাট তোমরা কি বুঝছো এই ডেমনস্ট্রেশনটা, what's happening here? So let's try to understand what's happening here. So এখানে যেটা হচ্ছে is you have your copper coil. So এরকম copper coil একটা, and copper coiler ভিতর দিয়ে যখন হচ্ছে তোমার এটা পড়বে, ম্যাগনেটটা পড়বে, something is slowing it down. And যেহেতু O levels এ GC তে এটা ছিল, I used to discuss it. So কেউ কি রিকল করতে পারবা কি ছিল the answer? Because O levels এ ছিল এটা, এই পার্টটা at least. কি রিপেল করে? আমি ড্রপ করে নিই তো easier হবে। এই যে this is the copper coil, right? And আমি কি করব, এখানে ম্যাগনেট থেকে ড্রপ করব। So this is my magnet going into the copper coil there. এখন বলো কি বলতেছিলা? অনেক কিছু বললা তো। Right. In the copper. Right. And why is it opposite? Because of why different poles? Different poles or same poles? Same poles. Acha, okay. Kachi, anyone else wants to try? Acha, I'm ki hocche. So essentially the thing that's happening here is that you have a pole here. Let's say it's a south pole, right? And or a north pole. And jeta hocche a magnetic field drop korlam. So put the pole here. That's a north, right? And I drop this magnet. As this magnet is falling through the copper tube, right? The magnetic field lines are being cut by the copper tube because it's going to go through it, right? As the magnetic field lines are being cut by the copper tube, what's induced in the copper tube? EMF. And because the copper tube is a complete loop like that, what starts to get generated in the copper tube? A current. Because, you know, EMF pulling into enough now, you need to have current. And now there's current flowing through the copper tube as the magnet is falling. Whenever there's current in any kind of material, what does it produce around itself? A magnetic field. And this time, this copper tube here will produce a magnetic field such that it wants this magnet, opposes the motion of this magnet, right? So as the magnet tries to fall here, let's try to see what happens here. At this lower side of the copper tube, right? What would you see? What pole will be generated on this side? North, right? Because you're trying to oppose it, right? So oppose korte hole you'll have to do something that's going to slow it down. So you can have a north pole generate hobe. Now at the top, there's a south pole there, right? The south pole will also be cut by the copper coil, right? Because there's a magnetic field at the top. So je ekhane south pole ta cut hocche. Can you tell me what pole will be generated due to the cutting of the south pole on the top? আবার রিপিট করি, আমার এই নটটা কাট হচ্ছে, ইএমএফ ইনডিউস হচ্ছে, কারেন্ট জেনারেট হচ্ছে, অপোজ করার জন্য নট জেনারেট হলো, because not repels not. I hope you understand, right? But the south here is also been cut by the copper coil, right? And because of that, what will be induced here? EMF, current, right? So what pole will be generated there? Okay, how many of you think at the top you're going to have north pole? At the top here, a north pole. Acha, okay. And how many of you think it's going to be a south pole at the top? South pole, acha. So the idea of Lenz's law is that it tries to oppose the motion. Oppose mane buঝছো to, but it wants to prevent what's happening. Tomar south pole ta niche chole jacche. I have an option for you. Make a pole here so that the south doesn't go away from you. What will you make? North. Okay, south dile to dhakka de shoray dibe oটাকে. It's not opposing, it's actually assisting it, right? So it's actually going to be the other way around. So ekhane north pole generate hobe. What's the consequence of this? That uporeo north pole generate hocche, nicheo north pole generate hocche. So ora jeta korche ekhane they connect a CRO, cathode ray oscilloscope, right? And they want to see the EMF generated as the thing falls. So I'm questioning your complexity barachi, okay? So first question is like, what happens? So it slows down because of opposition, right? Second question, how does the EMF look like? So when the magnet enters here, তখন magnet field lines are being cut, একটা EMF spike দেখি আমরা, so আমি গ্রাফটা দিয়ে দিচ্ছি তোমাদেরকে, এরকম দেখতে আসে। And then as the magnet falls to the inside, let's say যেটাকে A বললাম, এটাকে B বললাম, as it falls to the inside from A to B, we find there's no EMF. Though there are field lines generated, current produced, EMF দেখি না কোনো আমাদের CRO তে। And once the magnet leaves the coil, we again find an EMF, but this time the EMF is not positive, it's going to be negative. Not only that, there's something else. What is different about it? Yeah, it's going to be much higher, right? And much narrower like that. So tomaderke last time this question came for 4 marks, explain this observation. Okay, so let's start with the first observation. Keno ekta prothome spike generate hoy? I think that's pretty well understood. When the magnet is moving in and it's like there, isn't only one pole cut at the moment, and one pole being cut at the moment induces EMF, and that's the EMF. And EMF ta barte thakbe the closer and closer the magnet gets. Why? More and more field lines have been cut. But once it enters and goes to the inside, we find that there is no net EMF out there. What's the observation behind that? Constant speed. Nah, it's accelerating.
There is no change in magnetic speed. There is no change in phi.
There is change in phi. No, to এটা কেমনে induce হবে? It's accelerated, right? No. Both the poles are being cut. Then why would it be 0? Cancel out. Acha. Okay, anyone else? তোমার কি কোশ্চেনটা বুঝছো যে কেন মাঝখানে 0? So one of the opinion is what, that the constant rate বলছো, constant speed, right? That's accelerating. তোমারটা ছিল the net phi is 0, like change in phi is 0. No, there is actually change in phi, acceleration যেহেতু হচ্ছে। Your one was constant phi, মানে there's no change in phi or a constant phi, they're two different things. But if there's a constant phi, then we'll have a constant EMF, right? So yeah, so shouldn't that give you a variation here? Why is it flat? If it's accelerating, the field has been cut, then there should be EMF generated. Exactly, right? So if it's accelerating, there should be some EMF here. Why isn't there any EMF here? So the reason behind that is we have to look into the structure of a coil. So let's say there is a battery like this, and a battery shate I have a coil here. Okay, make a coil niye ashi. Look at this. It is important, okay? These are the A-level stuff. Can you tell me if my coil is positioned like this, and current is passing through my coil, what is the requirement for so which pole would be generated here? So আমার current এদিকে যাচ্ছে like that, and current is, let's say, pointing this way. Can you tell me which side is the north pole? Up, right? So that's clear. Does everyone agree with this? Is there any confusion that this is a north pole at the top? Acha, okay, fine. Now that is like this, right? Do you see the coil generated at the north pole at the top? Doesn't that mean that the current in the coil is going like this? Like imagine the coil, like imagine the tube here being like a giant coil. Doesn't it mean that if there's a north here, the current is flowing like that through the coil? Do you agree? Acha, fine. But our nicheo ekta ki generate hocche north. So if I want to replicate the same diagram on the other side, right? But I want my north pole to be on the bottom like that. এটাই তো করতে হবে, right? এটা করার জন্য কি করতে হবে আমাকে? ব্যাটারিটাকে রিভার্স করতে হবে. So the plus is going to be to the top and the minus is going to be, or the other way around, right? So like that. Do you agree? So we can say that this is the setup, which side? At the top part, এই জায়গাটায়, right? And this is the setup, which part? At the bottom part. Because দেখো উপরে একটা কি জেনারেট হচ্ছে এখানে north, নিচে কি জেনারেট হচ্ছে north, right? What do you think would happen if I connect these two? Right, it cancels out. Look at this, the batteries are opposing each other, right? So what's going to be my net EMF? 0. That's why they will try to push the electrons both ways, and they do, but the electrons don't go anywhere, because what is my resultant here? 0 তার জন্য মাঝখানে you have a what EMF here 0 EMF because the net is 0 because the upper part here is pushing the electrons that way, the lower part is pushing the electrons that way, and it's the same magnet, so they're pushing by what amount? Same amount, because the strength is the same, right? And that's the reason why মাঝখানে তোমরা কোনো কিছু পাও না. Do you get my point? But it's accelerating, not at 9.81. It's slow, obviously. So by the time it moves out, isn't it moving faster than it entered? So when it's leaving here, if the rate of falling is faster, wouldn't the cutting of field lines be higher? Wouldn't the EMF be greater? That's why you have a higher value here. Okay. Now, একটা জিনিস একটু careful থাকবা, এটা হচ্ছে প্রায় জিজ্ঞেস করে যে why is the time shorter here compared to the start? Yeah, the speed is higher, তার জন্য time is smaller. But can you tell me what does the graph area here provide? এই যে এটা যদি EMF হয় আর এটা যদি time হয়, what does the gray area under the graph here generate? এই যে এই এরিয়াটা, sorry, এই যে এরিয়াটা এখানে কি জেনারেট করতেছে? Or what is the quantity that the area provides to you? Energy by time. What? Where? Energy. This is EMF, first of all. আর হচ্ছে I asked area. Why do you divide them? EMF into time. Power. তোমরা কি বুঝছো? মনে হচ্ছে না তো, একদমই মনে হচ্ছে না. এইটা হচ্ছে EMF and this is time. I'm asking you what quantity does